Good afternoon, students. In the last lecture, we were briefly looking at the internet structure, basic building blocks, etc. And towards the end, we were looking at the different requirements and the associated problems, okay, based on, for example, what users expect or require, what the network providers can provide, and what is the gap, what are the issues here. Move on further, okay, we again revisit the whole internet architecture, okay. And if you look at this figure, you can see that there are mainly there are three different components. One, network edge. Okay. So this is the same figure which we have seen in the previous lecture. You can see that there is a home network here, and there is a cellular mobile network. There is an institutional network and the service provider networks. Okay, and okay, if you identify different parts, the first one is network edge. Network edge means the edge of the network that is in the beginning or at the end. Okay, that is the end side of this. So you can see that on the network edge we have all the hosts, mobile phones, computers, let's say servers. So they are all in the network edge. Okay, then come what is called access network. Access network is basically the network which is used to connect the end users or end hosts to the network or internet. Let's say you want to connect to the internet. So you have the laptop. How you connect to the internet? You should do this via an access link or access network. So let's say you use Wi-Fi to connect to the internet. That Wi-Fi is an access network. Okay. Similarly, if you use, let's say, LAN cable to connect your system or your TV or game console at home, then that particular LAN port is a wired access network. Okay, and for example, cellular mobile, that is 4G. 4G is an access network. That means if you don't get connection, Wi-Fi connectivity either in the campus or in the home, okay, particularly when you move outside away from Wi-Fi, you try to connect to internet through 4G. Am I right? So 4G is basically an access network. So this is used to get an access to internet. That is the first mile or last mile link. Okay. And we have other kind of network called network core or core network, which is basically a network of interconnected routers or switches. So you can see here service provider network, where you can imagine outside the campus or the home. Okay, there's a network of routers, okay, which are managed or administered by service providers, that we call it as network core or core networks. Okay, and there could be switched network or routers inside maybe a big campus or company in addition to the access network, but minimum at the company or let's say at home we have, let's say, wireless access network, say this is a wireless access point, for example Wi-Fi, and also some wired access network like Ethernet and other things. Okay, what is an access network? As I said before, this is a network which is used to connect the end systems to the network or the internet. Okay, that means it's used to connect end system to edge router. Maybe edge router you can imagine as the first router to which should be connected to get access to the internet. Is that fine? That is the access network. Okay. There are different kinds of access networks. One, residential access network, which we briefly looked at earlier, which is inside the residence. Okay, it's how we get access to an internet by means of Wi-Fi. So Wi-Fi is an access network. So this is an access network. Similarly, at home, we can connect our, let's say, desktop computer or let's say smart TV or game console, okay, which are not generally mobile and at the same time which need maybe higher bandwidth. Okay, we usually use some LAN cable to connect to our router. So wired connectivity is also there. This is also an access network. So similar access networks exist in the enterprise network or the institutional network. You can see this is a wireless and this is a wired network. Okay? And as I told before, mobile access network, this is based on cellular mobile stations. So you can see the mobile tower. So this is the access point. The tower is an access point to which our mobile phone or laptop or let's say if they have 4G connectivity, okay, connected to the cellular network. So this is also an access network. Okay. Later we see that the working or the issues or functions carried out in access network and the core network are different. Okay. There are different kinds of functionalities carried out at different types of networks. Okay. And if you go through the books, you can see different kinds of access networks here and there. So I try to summarize this, okay, or list them as few basic access network. Okay, there are as such there are 6 access networks which we are going to look at briefly, starting from the telephone network based access network, which is based on DSL modem, digital subscriber line. Okay. This may not be written there in the notes. Okay, maybe later it is there in the next slide. Okay. And see, for example, if you want to have an access network or broadband access from your home, there are different ways. One, nowadays countries like Singapore, fiber-based broadband services are becoming quite popular, and in Singapore, almost every home is connected by fiber. Okay, so we increasingly tend to use fiber network. Agreed or not? I believe you are all familiar with fiber-based broadband, which provides 500 Mbps, 1 Gbps, even more than that. Okay? So fiber-based access network is one of the popular networks now. Okay. And until recently, in Singapore, there are other kinds of networks which are also popularly used. Even now, they exist. Okay, and they are promoted by either the telephone service provider, let's say Singtel. Singtel promotes DSL modem-based internet services or broadband services. Okay. Similarly, you take any TV service providers like, let's say, StarHub. Okay, they promote what is called cable modem-based access network. Okay, is that fine? Are you familiar with ADSL? Have you heard about this term? So if you want to subscribe to Singtel, let's say for broadband access, they provide you a modem, ADSL modem. Okay, asymmetric. There are different DSL, ADSL, SDSL, HDSL. There are different DSLs. ADSL is popularly used. Okay, but generally we say DSL. It's a DSL family of modems. Okay, digital subscriber line. So that is promoted by Singtel. StarHub promotes cable modem. There's a different box. There's a cable modem. Okay, so they promote this. So you go to any country. Okay, telephone service providers promote ADSL technology, and the TV channel service providers, they promote cable modem-based broadband services. But countries like developed countries like Singapore, slowly, they are diminishing the ADSL or cable TV-based services. Even now, you can see that there is an effort by these telcos. Repeatedly, they say, go for, okay, you change to fiber, okay, from next month you don't get cable services, etc., etc. But in the world, still, these two are also popularly used. Okay, so we look at one by one the key principle. We are not going into the communication details or what kind of modulation technique is used, etc. But at least at the abstract level or black box level, we will look at how it works. Okay. So then comes local area wired access. Even when we say local area, it is localized in a small geographical area, maybe within a lab or house or small company, etc. So by means of cables or wires also, you can have an access network. One popular technology is Ethernet-based LAN or local area network. We will also briefly look at this. And similarly, local area wireless access. Okay, and a good example is 802.11 wireless LAN. Of course, there are different variants, B, G, N, AC. There are different variants of wireless. Okay, we call this as local area wireless access. When we say local area, that means it spans only few feet or few meters. Okay, you cannot have a wireless access point here and maybe after half a kilometer you cannot connect to that. Maybe few feet or few meters you can connect. Okay, so in your home, if you move away from your home, you cannot connect to the Wi-Fi, is it not? Then comes wide area wireless access. This is basically based on cellular mobile network. For example, 4G, 3G, 5G, all those things. Okay, it's called wide area because the cellular tower can be, let's say, few kilometers away from you. Let's say 10 kilometers away from you, still you should be able to connect your device to this. But that's more expensive. That's why we need to pay more for mobile data. Okay. Let's quickly look at one by one. Okay. As I said before, DSL, which stands for Digital Subscriber Line. Okay. Digital Subscriber Line. Maybe it may have some reasons why it's called digital line. Okay. Because if you take any telephone link or cable, okay, so telephone cable or telephone sockets, okay, so I'm talking about the telephone network promoted by the Singtel, the so-called landline telephone cables, not the internet-based telephones at home. It's a true landline telephone service. Okay, there's a telephone network, there's a telephone cable. Okay, there's a cable going out of your home. So you connect your telephone set to the telephone socket. Then you can, if you subscribe to this, you can talk. Right? And this telephone cable usually carries voice. Analog signal, okay, up to let's say 300 hertz or 300 hertz plus, etc. Okay? But after outside premises, okay, after certain point when it meets some multiplexer, etc., then it will be converted to digital. Okay, but this remains analog. Okay, and this technology. Okay, earlier there was another technique called dial-up modem. Have you heard of dial-up modem? It's in the history now. Have you ever used dial-up modem? Maybe some of you, maybe 10 years back or something. Okay, so it was very slow. I mean, it's just instead of telephone voice signal, the same telephone link can be used. We don't have much time to discuss about this, but it used to give only 54 kbps. So until few years ago, we all depended on this kind of dial-up modem to connect to the internet. Just imagine 54 kbps is very small, right? Now we are not even happy with 54 mbps. Okay, 54 kbps is small, but effectively when we use it, you may get around 1 kbps or 2 kbps, sometimes less than a kbps. So just imagine. Okay, but during those years, not much video-based or heavy image-based applications were not there. So we were mainly using for some simple web browsing, text-based applications. So should be fine. Okay, just to read some newspaper, to read some email, not for other purposes. Okay, so how it works? So inside home, okay, let's say we have a telephone socket. So we can have simultaneously, you can have your telephone connected to that, and the service provider gives you a modem called DSL modem, okay, and to which you can connect your computer. There will be a port, okay, LAN port or something. But what is practically used is that you connect a router, wireless router, to this modem, so that okay, all your devices can be connected to the router. Okay, so later we extend this further, but let's briefly look at how it works. And there is a dedicated telephone cables running from every home. From our home, the cable which runs out our home is not shared, okay, until it goes to the part of telephone service network. Okay, so maybe logically we can say that this all along goes until what is called, let's say, CO, central office. It's a telco's terminology, central office, where you can imagine some network elements or equipment are kept. Okay, so there is a multiplexer called DSL access multiplexer, which is located there, and the links or the signals which comes from every home, okay, is received by this DSL access multiplexer. Okay, and the voice which is transmitted here and the data signals which is transmitted from here, they are transmitted at different frequencies on a dedicated line. Dedicated means different homes have different cables. Line means link. Okay, don't think that it's a spelling mistake or anything. Line means link, cable. Okay, and when it goes here, it will be separated. That is, voice signals will be separated out, and this will go through telephone network, which is already in place. and the data signal will go through the service provider network based on the routers and other things. Is that okay? It's a very simple principle. So what we are trying to say here is that already there is a telephone link or cables existing in every country, and better we make use of that telephone cables to transmit data from our home. So that is the key idea here. But the transmission rate, that is the rate, how many bits we can transmit per second, that is not that high. And on the upstream side, when you say upstream, that is uploading from your home to another place, maybe a remote server or anything. The upstream speed is very few Mbps, and the downstream speed is about 25 Mbps, let's say up to, later went up to, let's say 50 Mbps, not beyond that. Okay. If you want to have higher data rates, then go for fiber-based networks. Okay, 500 Mbps, 1 Gbps or more, 2 Gbps, etc. But usually downstream rate is higher compared to upstream rate. Okay, so it's a kind of asymmetric. Okay, because naturally we tend to download more compared to uploading. We take more than what we give. Okay, but the gap is reducing. Gap is reducing means we also now increasingly tend to upload more and more, send more and more videos, and also pictures and other things. So we also need more bandwidth on the upstream side also. It's not only for the downstream side, but still the downstream bandwidth usually is higher compared to the upstream. Okay. Now look at the cable-based access network, which is promoted by, as I said before, any TV service providers like StarHub. Okay, and in terms of the black box level, it looks similar to that, but only thing is the difference is we use the TV socket, cable TV socket in our house, okay, to connect to TV as well as to a modem which is provided by the service provider. Okay, and our computers are connected to this, or we can connect a router, wireless router, to this modem, and all our other devices like phones, computers can be connected to the router. So how does it work? So it leverages on the existing TV network. Already there is a cable-based TV network is there, that we call it as distribution network. So in TV distribution network, there is a cable head end, something similar to CO, central office. There's an office from where the TV signals are so from here all the TV signals are broadcast. So this is basically a broadcast or shared network, shared distribution network. Because TV signals, TV channels, naturally it's a broadcast. Am I right? The TV service provider, okay, so he has few channels, 100 channels. So every channel, different programs are broadcast. Broadcast in the sense that the same signal, okay, whether it's in our home or somebody else's home, okay, channel number 5 means channel number 5 content will be the same. Am I right? Similarly, every channel. So from what we receive is a broadcast. That means everybody receives the same thing. And you can use the remote to tune to some particular frequency, okay, then you can watch it. Okay, so every channel uses up certain frequency or bandwidth, okay, and when you use remote, you are actually tuning to that particular frequency, so you are watching that particular or corresponding channel. Is that fine? And obviously nowadays these TV service providers have control over it. They provide set-top box through which they control which channels you can watch, okay, which channels you cannot watch based on your subscription. Okay, otherwise, as far as the cable is concerned, okay, it carries all channel signals until your home. So now the question is, can we make use of some channel bandwidth, TV channel bandwidth? Let's say there are two standards, 6 megahertz or 8 megahertz bandwidth used for every TV channel. So if we can make use of the TV channel bandwidth for data transmission, then that is, we can make use of that for internet purpose. So you can see that there are some video. There's a video channels means the normal TV channels, and also there are some channels which carry data. Okay, that could be sent out through the television distribution network, which is already existing. Okay, so what is actually practically done nowadays is that we use what is called HFC, hybrid fiber coaxial cable. Coaxial cable is the cable which is used for TV. Okay, the TV cables are coaxial cables. If you want to read more on that, I would suggest you to refer the book or material. Okay, so what are the characteristics of coaxial cable? Okay, similarly, the telephone cable are the telephone cables are basically twisted pair copper wire kind of cables. Okay, this is a different cabling used. So what's happening here is that from the so-called cable head end, okay, there is a single fiber. There is one fiber all along going near the housing premise. There is only one fiber coming all along the way near your premise. Then from there is a distribution network. This is a cable based, coaxial cable based distribution network. Okay, so instead of starting the the coaxial cable network from the cable head end to the home, just use one fiber closest to the premise. Then from there serve few hundreds or few thousand homes through coaxial cable. That's how what's happening. So it's called hybrid because it uses both fiber as well as coaxial cable. And with this modem and with this framework, okay, up to 30 Mbps downstream bandwidth or transmission rate is achievable. It's also, you can go up to, let's say, 50 Mbps, okay, or maybe up to 100 or something, but we are not able to go beyond that. So that's why there's a need for fiber based network. Okay, so note that this cable network is a shared access network. That means multiple homes, they share the same cables, unlike the telephone service provider where there is a separate cable for each of us. That does not mean that, okay, if you use telephone based modem, ADSL modem, we get higher rate than this. No, there is no such proof. Okay, it depends on many factors, which you will slowly understand what factors will affect the throughput or data rate, the throughput and other things. Fiber network is also an access network which is used to connect our devices to the internet. Okay, they are quite popular now, becoming more and more popular. Okay, so there are few advantages of fiber based solutions, which we generally call it as FTTH, fiber to the home solution. Okay, and this has, using the fiber, optical fiber, okay, has some advantages. What are the advantages? It provides huge bandwidth. Let's say we are able to get few gigabits per second. Few gigabits per second is actually the data rate or transmission rate. So when we say gigabits, that means this is 10 raised to the power 9. That means in 1 second, 10 raised to the power 9 bits, that is 1 billion. Billion, not million, billion. Okay, 1 billion bits can be transmitted in 1 second. Is that okay? Similarly, 1 billion bits can be received in 1 second. That's what it says. In fact, on the fiber, the usable bandwidth is about 25 terahertz. Okay, there are different wavelengths on which transmission can take place, but there are some, let's say, wavelengths which are usable. Usable means without not much attenuation and other things. So the bandwidth available is about 25 terahertz. Okay, there's a true definition of bandwidth in hertz. Equivalently, you can imagine that, okay, terabits of data can be transmitted in 1 second. Okay, so that's advantage. There's another advantage, that is the bit error rate is very small, 10 raised to the power minus 12. Is less than 10 raised to the power minus 12. That means at most 1 out of 10 raised to the power 12 bits can go wrong, maybe damaged or maybe corrupted. Okay? For any medium, any communication medium, there's a small chance that the signal will be damaged. 1 may become 0, 0 may become 1. Okay? So there is a possibility of error, but the error possibility here is very low. And there are other advantages as well. For example, the distance from the service provider's central office to our home premise can be up to 20, some literature says even go up to 40 or etc. Let's say safely up to 20 kilometers can be there. The remote office from where the fiber starts, okay, until our home can be up to 20 kilometer without much problem. Okay, if it goes beyond that, maybe we may need other amplifiers or regenerators, kind of things. But if you consider DSL or cable-based modem, okay, the remote office should be within 5 kilometers, not more than that. Okay. Now let's say there are n subscribers like this. Let's say there are n homes. That means there are n subscribers, and let's say the distance from here is L kilometer. So what's happening is a very simplified general structure of the optical fiber-based optical network, which we call it as PON or passive optical network. We are not going into much details onto this, but you just have a brief idea of this. There is an optical unit or element called OLT. OLT stands for optical line terminal. Okay, it stands for optical line terminal, which is located at the central office. And there is a fiber running from this central office all the way, okay, to the near our home or near our apartment or some premises, okay, the residential premises. So once it reaches there, okay, the dimension is not proper, but this is very close to the homes. Don't think that this distance or distances are quite high, okay. So once it reaches here, it goes through what is called passive splitter or coupler, from where there are small fibers running out to individual home. At home, we have an optical unit called optical network unit, ONU, optical network units. Maybe commercially they call it as ONT, if I am not wrong, ONT. Okay, if you subscribe fiber broadband, they provide ONT, some box ONT. Okay, so we call this as ONU, optical network unit. So every home has ONU. So now there are two-way communication. So what is done is the downstream side, it's a broadcast. So whatever is sent from this CO, this OLT, the line terminal will transmit. Please note that once it's transmitted through optic fiber, the transmission signal is in the optics light form. Okay, but inside the router or our computer, the signals are stored and processed in electrical form. But once it is transmitted, okay, that means electrical signal is converted to optical pulses or optical light waves, optical pulses, and it will traverse like a light through the fiber. So it's a passive coupler, that means it doesn't need any active component, power and other things. So it simply splits. It's a splitter. Passive splitter means it sends everything to everybody. Okay, it's a kind of broadcast. And every ONU has some identifier. Let's say this is ONU 1, this is 2, this is 3, just an example. So every packet, the piece of data will carry some identifier. Okay, so based on the identifier, it is decided, okay, these packets are meant for this data is meant for this data is meant for this. Otherwise, every home receives all data, but they will filter it out. ONU will filter it out. It will not pass every data to your computer. Okay, is that okay? But the problem is that the upstream transmission, that is from home to the internet, this is upstream. Upstream transmission is a bit problematic. Why it's a problematic one? Because it may so happen that more than one user from the house, they try to send data at the same time. So until here there is no problem, but after this they are coupled. That means after this there is only one fiber. There is only one fiber. Okay. So on a single fiber you cannot send multiple bits at the same time. So there should be some kind of coordination among this. Okay. Actually there is a protocol running there. For example, EPON, Ethernet based PON. Okay, which will decide. Okay, which will allocate. I mean, I'm just telling you some key idea. Okay, which allocates some slots. Okay, during time slot 1, okay, this home user will use this, can send data. During this period, for this much period, okay, you can send data. Okay, so it is based on the demand. Let's say user 1 has lot of data to send compared to user 2, then user 1 will be given more time to transmit. Okay, is that fine? Any doubt? And as far as wireless access network is concerned, as we seen before, there are broadly two types. Okay, local area wireless access and wide area wireless access. Local area wireless access, an example is the Wi-Fi, which is used inside the house or inside building or inside a small room. Okay, so theoretically, in the ideal case, maybe it can go up to 100 feet, but practically, because of the wall and other obstructions, okay, maybe few, sometimes 10 feet, 20 feet, so it can go. Okay, if there are no obstructions in ideal conditions, maybe it can go up to, let's say, 100 feet. Okay, so this is basically the wireless access point. This is how we represent. Okay, to which our mobile or laptops, they are all connected by wireless means. The rate is 1154 Mbps, and it's going further with other variations which we discuss later, like because B and G are the very basic ones, old ones. Okay, but there are new evolutions, new versions. On the other hand, when we say wide area wireless access, as I said before, this is based on the cellular mobile network. There's a cellular tower to which our systems are connected. Okay, so use, let's say, 3G or 4G. 4G is also called LTE. LTE stands for long term evolution. Okay, but now we are going towards 5G. Maybe very soon we may get 5G. Okay, with higher data rates. And normally the data rate is from 1 to 10 Mbps on the cellular network. But I just say and more, because increasingly with 4G and all, that has been claimed that okay, you can use up to 100 Mbps, 300 Mbps. Okay, now with 5G, maybe they may promise 1 Gbps, etc. We do not know. Okay, is that okay? But usually the cellular mobile network data rate is smaller compared to Wi-Fi. Okay, and the cellular mobile data is also more expensive because the infrastructure cost is more. Okay, the service provider has to build or install so many towers here and there, and that has to be managed, etc. Okay, but wireless Wi-Fi connectivity is maybe cheaper, and the bandwidth also with fiber broadband and all, that becomes available for cheaper rate compared to the mobile data. Okay, let's look at a bit more details onto the home network. Okay, so we have seen three kinds of networks. Okay, let's look at the first two kinds, cable or DSL modem based. That means this is based on the TV, this is based on the telephone. In this case, we have a modem, whether it's a cable modem or ADSL modem. That modem can be used at our home. As I said before, cable modem means you connect to the TV socket. ADSL modem means you connect to the telephone socket. Okay, and then it's connected to what is called a router. This is the router, and this is the wireless access point. This is the wireless access point, and this router has a number of ports. Ports means is a, let's say it's called LAN port, Okay, usually these ports are based on Ethernet based port. Okay, as I was telling, this the wired connectivity is bit faster compared to wireless connectivity. So devices like smart TV, game consoles like Xbox, PS4, those kind of things we want to connect through the cables, because when you use game console and all, some games are increasingly, many games, the capacity is, the size is quite high, 50 GB, 60 GB data, right? Downloading 60 GB takes more time, isn't it? We may not do it, we may not want to do it by wireless connectivity, but we use cables to do that. Okay. But practically what's happening is that these two, the router and the wireless access point, they are combined into a single box. Because at home, when you have, let's say, wireless router at home, there are many companies, right? D-Link, TP-Link, there are many companies, routers, okay? They call it as wireless routers. Actually, it has both the router and the access point together. Logically, we show separate boxes, but commercially, they come in one single box. So the purpose of this is to connect to the devices by wireless means, and the router has few functionalities which we will be discussing one by one later. But roughly, you can imagine that it does some routing or forwarding of packets, okay, from the devices inside the home and outside the home. And it has also, may not be very sophisticated firewall for security purpose. Some firewall functionality is there in the router, and also it does what is called NAT, network address translation, okay, which we also will be studying later. But at this stage, you just imagine this, what is NAT? Okay, let's say you take a house. How many devices are there inside a house? How many internet based devices? Any idea? You take a typical house in Singapore, okay? There are some mobile devices, mobile phones, right? Sometimes even the old mobile phones, you may not be using it, okay? Maybe a backup phone, but still, that's also a part of, that also needs some address, am I right? So every device, IP-based device, let's say mobile phone or laptop, desktop, or smart TVs, smart cameras, okay, game consoles. So now there are other smart things coming up, okay? So there are many smart devices coming up, everybody needs an address, okay? So if a home has, let's say, 10 devices, then we need 10 addresses. If we have millions of homes, or in the world billions of homes, okay, you just imagine how many addresses we need. So we need lots of addresses. But currently, when we use, let's say, IP address, okay, this is popularly used. So this IP address is basically a 32-bit address. 32-bit address. 4-byte or 32-bit address. You can easily check your device IP address. And this IP address, since it's 32-bit long, we can have 2 raised to the power 32 addresses. That is approximately 4 billion addresses. 4 billion addresses, not more, approximately, but some may not be used at all, okay? So, but when the network evolved, maybe let's say 70s or 80s, okay, people did not think that the network will grow that big, internet will grow that big, okay, billions of devices would be there, okay? So there, those days, maybe only some universities and some research labs, some companies only had the so-called networks, okay? Not like this. Now everybody, every home, everywhere there is a network, okay? But at that time there was no such network. So they thought maybe 32 bits would be sufficient, but it's not so. So since more and more devices come inside our home particularly, okay, we cannot give more and more new addresses. So instead, at a home, only one IP address is given. So only one IP address is given for a home, okay? And all other IP addresses inside the home, all the devices, whether you have 10 devices, 20 devices, okay, all these IP addresses are hidden Hidden in the sense, when the data goes out of your home, okay, it will carry the IP address of your home, the same IP address. Inside the devices, inside the home, okay, that means for the external world, okay, it all comes from only one device, not from multiple devices inside the home. Is that fine? Similarly, from outside, let's say you are trying to download something, web page or video clip or whatever it is. So when it passes through this router, this should go to the correct device. Am I right? But for the external world, it uses only one address. So when it reaches your home, then the correct address should be translated to. Okay, this is meant for mobile phone 1. This is meant for laptop 1. Okay, so that translation is done by this, by means of NAT. So it helps us to save the address space. Okay, so we are reusing the addresses. So basically, the addresses inside the device, the home, they are dummy addresses kind of thing. Dummy addresses, not the real, because we can reuse it. Okay. Enterprise access network, this is another kind of access network, is a campus network or company network. So here also, maybe like you take our university, we have the wireless access point. So you can connect your devices by Wi-Fi. Here and there are access points. Similarly, let's take our offices or this desktop computer or lab computers or offices. They are connected to the switches by wired means. Okay, this is a wired network. So there's a wireless network. In addition to that, we have what is called the servers, which are normally located in, let's say, data centers. Okay, computer center or data centers. So nowadays we use the term data centers, where all the data servers, storage are located. So all our data and the required services, they all come from the data centers. Okay, and usually these servers are connected by cables, not wireless means. Okay, so this part is different from our home network. Okay, and similarly, they have at least one router which is connected to the external service provider network. So the same figure we put in a different way. Okay, this can have, let's say, switches or routers. Okay, or this can be a broadcast network. This link, okay, to which multiple computers are connected, basically it represents a broadcast. So later, slightly later, we look at the broadcast network, etc. So it can have a switched network like this, or broadcast network, or wireless network, etc. Okay, let's move on to the new topic, network links. Okay. So one classification of network link is, what is a link? Link is a communication channel which is used, or communication cable or channel used to connect two devices. Okay, either our computer to a switch or router router to router. Okay, you take any two devices, we can connect them by means of link. A link could be wired versus wireless. Okay, so there's another way of looking at the links. The link could be broadcast links or point-to-point links. Okay, so we can look at from different perspective. So let's look at, okay, some of the key characteristics of this. Before that, let's ask this question: how fast we can transmit through a link? We know there are different kinds of links: wireless link, Wi-Fi, okay, where the signal is propagating through wireless media. Similarly, there are other links like twisted pair copper wire. Good example is our telephone cable. Okay, that's also used in the Ethernet, for Ethernet cable to connect your computer to other ports or router. Okay, and we have coaxial cable, which is normally used for TV. TV cable is coaxial cable, and we have fiber-based cables. So there are different kinds of medium, communication medium. Okay, but how fast we can transmit through a particular link? The meaning is that how many bits can be transmitted in 1 second. It doesn't mean that we can transmit at any rate through any link. No, we cannot. Okay, there are the physical media restrictions, so we cannot do that. Okay, So, but before looking at that, you just need to remember that data is transmitted bit by bit in a serial fashion. So many times you may get confused. When we say data is sent through a link, don't think that the entire data or bunch of data or bytes are thrown into that. No. They are transmitted bit by bit. That means at one end of the link, there is a transmitter. Then maybe you can imagine, okay, for every clock tick or something, one bit is sent, bit 1, bit 2, bit 3, bit 4. So the bits are transmitted one by one. Of course, bits will be translated to or mapped to signals, so let's not worry about that, okay. But imagine that the data is transmitted bit by bit, okay, from one end to the other end. It uses some transceivers, transmitter one side, receiver other side. Similarly, transmitter other side, receiver this side. Is that fine? Then, a link is characterized by different parameters. So frequently we encounter this bandwidth, data rate or transmission rate, channel capacity or link capacity. Okay. These three terms are related to each other, but there are small differences. Okay. So let's look at bandwidth. When we say bandwidth of a communication channel or bandwidth of a link, okay, what does it mean? As the name says, bandwidth is width of the frequency band. Width of the frequency band, okay, which is used for transmission. So to put formally, is the bandwidth of the transmitted signal. Bandwidth is width of the frequency band, the band of frequencies. Okay, transmitted signal as constrained by the transmitted medium, which is expressed in hertz. For example, if you take TV, this is 6 megahertz or 8 megahertz. Okay, the TV channel bandwidth is about 8 megahertz. So if you use, let's say, cable modem for data transmission, some channel frequencies or frequency band is used. So if you consider, let's say, the telephone link or let's say voice link, this is 3K or let's say 4K, 3 or 4 kilohertz is the basic voice signal. That's the frequency or bandwidth of our voice signal. This is expressed in hertz. The unit for bandwidth is hertz. There is another term, data rate, which also we looked at before. This is defined as the rate in bits per second. That is how many bits can be transmitted. Given a link, okay, you transmit bit by bit, bit 1, bit 2, bit 3, bit 4. So in 1 second, how many bits can be transmitted? So for example, if you have, let's say, 100 Mbps link, or let's say 1 Gbps fiber broadband link in our home, that means 100 Mbps means 100 million bits can be transmitted in 1 second. Okay. Usually our computers and all, it comes with 100 Mbps interface. So you can transmit at the rate of 100 million bits per second. There is, but do remember that the unit here is BPS, bits per second. That means it can be kbps, kilobits per second, or mbps, okay, megabits per second, or million bits per second, or gbps, gigabit per second, or billion bits per second. Okay. So similarly, we have terabits also, tbps. Channel capacity is another related term that's also measured in bits per second. But the difference is that this is the capacity. That's the maximum rate at which data can be transmitted over a link or communication path. That is the capacity. Okay. Data rate is the actual data rate. Capacity is the maximum. Okay. Maximum how many bits can be transmitted. Okay. And this is constrained by, later we derive some simple formula, what is called signal to noise ratio. That is defines the quality of the communication link. So based on that, the capacity is limited. It doesn't mean that we can send at any speed through a particular link. Is that fine? Okay. Now, all the three terms of related to each other, because usually when the bandwidth is higher, the transmission rate is also higher. When you increase the bandwidth, you can also increase the transmission rate. So they have a relationship among themselves. So, in our context, in this course context, okay, that three terms are used interchangeably. That means whether you refer the book or when I teach also or in the exam also, when I say the link bandwidth is 100 Mbps, okay, what actually I refer to is the data rate. Okay, I may say link bandwidth is 100 Mbps, but the true definition is, because it's 100 Mbps, I refer to data rate. Don't worry about it. Okay, whether it's a data rate or bandwidth, don't worry. Okay, but maybe in one or two specific context where we handle both bandwidth and data rate. Okay, when we study the relationship between bandwidth and data rate, then you can differentiate them based on the unit. Look at the unit. If it is given in hertz, megahertz, gigahertz, then it's bandwidth. If it's given in bits per second, then it's a data rate or transmission rate. Okay. Okay. There are two kinds of links: broadcast links and point-to-point links. What are those? Okay. How do we differentiate them? A broadcast link can be wired or wireless. Okay. Let's look at this figure. This is basically a wired broadcast link. So you can see that there is a link or cable. So you can imagine that there's a cable running along the wall. Okay, and there are few sockets there to which we can connect our host, that means our computers. Okay. So until recently, this has been a popular one. In fact, the very first Ethernet based network is, the traditional Ethernet is broadcast based, but recently we have Ethernet switches and other things. So instead of broadcast medium, we can directly connect to the switch. Okay, but still it provides a compatibility from the broadcast network. Okay, when you say broadcast, what does it mean? Broadcast means one to all. So whatever I speak, okay, you can hear everybody. That means it's meant for everyone. So I broadcast something. Is that fine? Multicast means a subset, one to many. Okay, one to one, there's another category. Okay, so broadcast one to one is a kind of point to point kind of thing. One to all means broadcast. So here in this case, you can see that this is a host. These are computers. Let's say A, B, C, D. Let's say B transmits data. That means whatever it transmits will flow, the signal will flow through the cables in both directions. So whatever is transmitted by B will be received by everyone, A, C, D, including B. Everybody can hear. Whatever I speak, you can hear, I can also hear. Okay? Is that fine? This is called broadcast. But what is the potential? I mean, the advantage here is that it's simple. It's very simple. You use just one cable, okay, and use computers, connect to that cable. Whoever wants to send, you send it. So everybody will receive the data, and every host will have some address, MAC address, hardware address. So based on that, that will differentiate. Okay, this packet or this data is meant for me. This data is not meant for me. Okay, this is somebody else's data. Okay, so it will not allow you to your computer. It will stop there itself. Okay, is that okay? Very simple. But the drawback is that because it's a broadcast, at any time only one can speak. Let's say I speak, you all listen. That's fine, no problem. But when multiple people started talking or speaking, okay, it's not good. Am I right? But in this case, if more than one computer try to send data, let's say B also tried to send, let's say C also sends some data, what happens? The signals generated by B and the signals generated by C both will be traveling, propagating through the same medium, so they will collide. There's a collision. There's a possibility of collision. Collision means the data value will be changed. 1 may become 0, 0 might become 1. Okay, data values will be affected. Okay, so that's a problem of collision. We need to take care of that. Okay, and another important point is that the link bandwidth is shared by everyone. What's the meaning of this? Let's say the link bandwidth is 100 Mbps. So there is a network adapter or network interface card which is also, let's say, 100 Mbps. The meaning is that when a computer wants to transmit, it transmits at the rate of 100 million bits per second. But a computer may not be transmitting all the time. Sometimes computer A transmits, sometimes B transmits, sometimes C can transmit. Am I right? So you take 1 second time. Let's say this is 1 second. During this time, let's say NA be the number of bits transmitted by A, and NB is the number of bits transmitted by host B, NC is the number of bits transmitted by C, ND is the number of bits transmitted by D. You add everything, this should be less than or equal to 100 million. Let's say A has transmitted 20 million bits, B has transmitted 35 million. Okay, so every host has transmitted some million of bits during a second period. Okay, so if you add everything, it should be less than 100 million, because the total capacity is 100 Mbps. At any time only one can use, not more than one. That means putting together, so that means this medium or bandwidth is shared by everybody. The total cannot exceed 100 million. It's not that when B is transmitting, C can also transmit simultaneously. No two simultaneous transmissions can take place. Okay? And this kind of networks are mostly used in local area network. They are used in local area network. Typically used inside the home or maybe inside small offices, a lab, etc. Okay, we don't want to use this in a wide area network or core network, service provider network, where we want to have higher capacity. The other type of links called point-to-point links. Basically, these links are used to connect a switch or router. So later, the difference between switch and router will be clear. Okay. So what basically a switch does is this. This switch has a number of ports. You can see 2 has 3 ports. Just an example. So in real life, it may have more than 4 ports or 8 ports. Okay, there could be many ports. So what is done is this: when one receives some data to 2, okay, let's say one wants to send some data to 6. Okay, it's not a broadcast link. If it's a broadcast link, one will simply broadcast only once. Everybody receives, only 6 will grab it because 6 knows that it's meant for it, and others will not take it. That's a broadcast. But point-to-point means this link is a point-to-point link because it connects only 1 and 2. Okay, only 1 and 2 can use this. So though we say it is a single link, this is the same as maybe 2 fibers, one in this direction, one in the other direction. Okay, even though we show this as a single line, the transmission can take place from 1 to 2, similarly 2 to 1. Only 1 and 2 can use, others cannot use. It's a dedicated one. Okay. So 1 has to send to 2, and 2 has many possibilities. It can send here or here. There are 2 ports which is possible. So let's say it decides to send it here. So we say that the packet or data is switched from this port to this port. Switch means internal forwarding. That's why it's called switching. Switch. So that means the data goes through every switch or router where this will be internally switched to another port. Okay, it goes here, then switch to this port, then goes here, switch to this port, etc. This is something like a road junction. Okay, you go all the way near the junction. In the junction, you take either this lane, this direction, or this lane, or this. Is that fine? So there's a switch. Okay. So these switched networks are normally used in the core network. Okay, it's a network of routers, and you can see that there can be many simultaneous transmissions. Let's say this is 100 Mbps. Let's say when one transmits to 6, 4 can transmit to 5, and 5 can transmit to 3. Okay, many simultaneous transmissions can take place. So the total throughput or aggregate data transfer rate can be more than 100 Mbps. Okay, because this fellow is transmitting 100 million bits 1 second. Same time, there is another fellow transmitting 100 million bits in 1 second. So the total will be within a second, could be more than 100 million second. So it is not shared, it's not broadcast, it's not a shared medium. Any doubt? Okay, now let's look at another kind of classification of networks. Earlier we have seen two classes of networks: access network like Wi-Fi, cellular, okay, local area network, etc., ADSL, cable modem, etc., and the core network. That's one classification. There is another classification, okay, maybe based on the geographic coverage and other things. Of course, there are other differences also. So based on this, a network can be classified into LAN, local area networks. It's a kind of access networks, metropolitan area networks, wide area networks. Okay, there are three classes: local area network. Okay, as the name says, it's localized inside the home or office or company. Then metropolitan area network, it spans a bigger coverage. Then wide area networks. Okay, and what is a network? Which we have already seen. It's a set of nodes and links. Node can be computers, switches, phones, routers, gateways. These are the part of the network. Links could be wired or wireless. It could be either twisted pair, copper wire like Ethernet or telephone cables, coaxial cables like TV cables, optical fiber. Similarly, it could be wireless, could be through satellite or by radio waves or infrared, short distance communication, etc. Let's look at one by one, okay, and we look at the key features of, let's say, LAN, MAN, and WAN, and we also see how they differ, etc. Yeah. Let's start with local area networks. As the name says, it covers or spans a small geographic area: office, lab, home, campus. When I say small, I don't give the exact number, how small it is, okay? Because if you look at the Ethernet, which is a popular local area network, okay, when it evolved in late 70s or 80s, okay, or 90s, okay, so 80s, 90s, those period, the network, when we say local, okay, as per the standard, it can be up to 2.5 kilometer. When you say local, if you take Ethernet, it can span, a single Ethernet network can be up to 2.5 kilometers. That means you can lay the cables around this hall, this building and other buildings. Maybe it may cover one big company, one single cable, single network. Okay, is that fine? But nowadays, if you take, many networks are becoming small and small. Okay, we don't want to have a 2.5 kilometer long network. Maybe we may want to have within a home few feet. There's a network, and office maybe one floor. We want to have a network. We want to use some switch, connect to maybe another switch, maybe another floor. Okay, so the networks are becoming smaller and smaller, but as per the standard, it can be up to 2.5 kilometer long. Yeah. Typically, it uses broadcast link. It's also called multiple access link or shared medium link. Okay, the same figure, you look at this. This is the broadcast link. This is also called multiple access because more than one host, A, B, C, D, they have access to the same link. Okay. It's also called shared medium because the bandwidth is shared by more than one. They take turn. Okay, one by one they do it. Yeah. And because it's a broadcast medium, because this medium is broadcast or shared medium and many people are using it, we need to have some control on the access of the medium. Who should access this medium, communication medium when? In other words, who should transmit now? Okay, somebody is transmitting. Okay, others should not transmit. Am I right? So what happens if others transmit? Are we going to prevent it? Or are we going to let multiple transmissions, then take some action, reactive action later? Okay. So how we are going to control the access? The same link is used by more than one. So this is defined under what is called MAC, Medium Access Control. Medium Access Control, MAC. Okay. There are different MAC, okay, in practice, but the most popular one is Ethernet based LAN 802.3. This is basically an IEEE standard. You don't need to memorize this number now, but slowly you will remember it, 802.3. And there are different versions of Ethernet and U, Z and other things. Similarly, we have wireless LAN, that's also local area network, which is 802.11. Again, there are different variants, BGN, AC, all those things. Am I right? So at least you have seen that letters, BGN and all. Okay. And there was also another, I say past tense, there was also another popular network, maybe 80s, 90s and all. There it was seen as a tough competitor for Ethernet. Okay, it's a competitor, that is token ring. Okay. We look at briefly, okay, the concept behind this, and you will also appreciate why one could win over the other one. Okay, there are few reasons. Okay, but what is important to note is that the bandwidth, okay, was quite low, maybe up to 10 Mbps. I mean, later increased to 100 Mbps, even 1 Gbps, etc. But for broadcast medium, it's mostly 10 or 100 Mbps, and for ring, token ring, okay, that is up to 16 Mbps. Okay, there are no new developments in the token ring. I don't think there are networks, new networks, I mean, commercially they are not popular now. Okay, but Ethernet is still popular. Let's quickly look at how they differ. In Ethernet, okay, it takes a very simple approach. Okay, so here, let's say this is Ethernet based network. That means this cable is Ethernet cable. It's basically some, let's say, could be a coaxial cable based. Okay, this can be a twisted pair cable which is used to connect it. Okay, let's say this is has capacity 100 Mbps. Now there are two questions. One, are we going to have a coordination among various hosts? Okay, you transmit now A, you transmit now. Next, host C, you can transmit your data. Then host D, host B. Okay, so if you coordinate the transmissions so that there is no collision, okay, there is one approach. The other approach is don't coordinate. Let everybody work independently. Let everybody work independently. Okay, so let everyone decide whether the link is free or not. Okay, if somebody thinks the link is free, okay, let it transmit. But the potential problem is, let's say host A, there's a network adapter here. It can sense the transmissions of the cable. Maybe it can sense some signal transmissions, propagation, which is going on here. So if it senses that some bits are flowing here, it will not transmit because it knows that it will lead to collision. Am I right? But when it senses its cable, here it finds that there is no transmission taking place. It's free to transmit its own data. But at the same time, another computer, let's say host C, that also checks, it senses the cable around this region. Okay, it finds that there is no transmission going on. Okay, even if it has started transmission now, it takes some time to reach this. Is that fine? So there is a small possibility that more than one host may find the link is free, because this fellow is checking on this part. Okay, this fellow is checking the link on the other part. Okay, they cannot check the transmission on the other end. Okay, so two started transmitting. If two start transmitting, because there is no coordination among themselves, they don't talk to each other. Everybody thinks only they are connected to the network. They just check, transmit. So it leads to what is called collision. It leads to collisions. So collisions are bound to occur in Ethernet. Because there are collisions, then this should take some extra measure, some extra action. So what does it do? It should have two mechanisms. One, you should have a mechanism to detect collision. So there's a way to detect collision. Something has happened because a host sent a packet and there's a way to know that this has some collisions. Okay? So if there is a collision, what happens? It should do something. What it should do? It has to send the packet or data again. Am I correct? But what happens if someone else also try to send the data again, retransmit? Because there is a collision, that means there are at least two people who are trying to transmit at the same time. But this host does not know how many other people are transmitting now. What it knows that there was a collision. It sent its packet or data, somewhere there was a collision. Okay? So what it should do? It should back off. Back off means it has to wait for some time before it starts transmitting. Okay, this back off details we will study later, but to put it briefly, every host, when it experiences collision, back off for a random time. Let's say host A back offs for 1 time unit. Another host will back up for 2 time units based on the random number. It generates some random number, and based on that, they decide to wait for a different time before they attempt to transmit. But the next question is, it may so happen that they may get the same number. This fellow gets number 1 when he generates random number. The other fellow also gets number 1. Okay, that means after 1 time unit of waiting, both will try to transmit again. Is that okay? So there is a possibility of another collision. Okay, so there is a way to handle such collisions in Ethernet. Okay. Then came the rival group, maybe other group, token ring. Okay. Ethernet was promoted by companies like Digital, Xerox corporations. Those companies were promoting Ethernet. At the same time, IBM was promoting token ring. So the argument was that, okay, Ethernet collisions can happen, so we don't want collision to happen. Okay, this is a key idea. So if the collisions should not happen, then there should be a coordination. Am I correct? Everybody should agree on some kind of schedule. So the idea is simple. There is a token. A token is a 24-bit special packet. It's a 24-bit data. It's a special bit pattern. Okay, so that small piece of data or packet will be circulating around the ring. So token is a special ticket. Okay, so if let's say host A wants to transmit, okay, some data, it has to wait for the token. When it gets the token, okay, it holds it, it transmits data. Once it is done, it passes to the next fellow, B. Then B checks whether he wants to send any data. If he has some data to transmit, he transmits, then passes the token to next one. Is that fine? So at any instant of time, the token can be on the link, or it can be with any one of the hosts. So only one can transmit. Two cannot transmit at the same time because there is only one token which is circulating. Is that fine? Okay. So this is a simple idea, and here the computers or the hosts are connected in the form of a ring. That's why it's called token ring. Okay. But even though it looks simple, okay, there's a token circulating, etc., etc. So it could not succeed. It could not compete with what is called Ethernet. Okay. In terms of performance, also there are some differences. For example, let's say only one host is active. In Ethernet, one host will always transmit, no problem. there's no collision. Okay, but here, let's say only one host wants to transmit, but still it has to wait for its token. Nobody is transmitting, but the token has to make one full round. Until that, it has to keep quiet, even though link is idle. Okay, and when it's transmitting also, it may not be allowed to transmit for a long time. There may be a design limit. Okay, you can transmit only for few milliseconds. Then you have to pass the token to next fellow. Okay, and there are also other issues, like though it looks simple, token management is another problem. Who generates the token? Who manages the token? Okay, and what happens if the token is with somebody, some system, and the system crashed? The token is lost. Okay, so who is responsible for monitoring the token, etc.? Usually, one of them will be elected as the leader. Is a leader who is responsible for generating the token. Then what happens if the leader crashes? Okay, what happens if the leader thinks the token is lost, but actually there was a delay in the token? Okay, the token is active, but it did not see the token for a long time, so it thinks that token is lost, so it should not generate a new token. If two tokens are circulating, then there will be collisions. Am I correct? Okay, let's move on to the next type of network, metropolitan area network. We are not going into the details of the working principles, etc., but you should know what kind of technologies are used in MAN and WAN. Okay, as the name says, it spans a medium geographical area, maybe few tens of kilometers. Okay, it interconnects a number of local area networks. So imagine that there are, let's say, LAN 1, there are many local area networks, LAN 2, LAN 3. Okay, so let's say different offices, different companies, homes, and all, they all have different local area networks. So these, the traffic coming out of different companies or universities, okay, will be carried by what is called metropolitan area network, which is beyond the campus. Okay, the first network was FTDI, fiber distributed data interface. It's called fiber based because first time it was using fiber. Okay, and the principle also something similar to token ring. The capacity was 100 Mbps, because during those period 100 Mbps was seen as huge capacity. Okay, now it may look small, 100 Mbps looks small, but during that period, initial period, 100 Mbps was quite huge. Okay, and there is a key difference between metropolitan area network and, let's say, the LAN. Okay, in metropolitan area networks, usually they have the concept of what is called fault tolerance. So what happens if, let's say, a link is cut? Because this is a network outside, it's not under direct control. The links are usually laid under the ground. Okay, is that okay? So there is a possibility that it could be man-made error or maybe natural disaster, or for some reason, if the link under the ground is cut, what should happen? What will happen? Okay, they all have some kind of fault tolerance capability. They will self-configure. Okay, they will route the traffic in a different way, and they try to make sure that they survive, the network survives even after failure. Okay, so then came SONET, a synchronous optical network. It uses what is called fixed time division multiplexing, which we will discuss later. So let's not spend time on this point, but you need to remember that there's a technology called synchronous optical network. There's an equivalent technology called SDH, synchronous digital hierarchy, which we look at later. Don't worry about it. But here the capacity link bandwidth available in units of 51.84. What is this magic number 51.84? How we get it? That you will see later. Okay, but right now you can imagine that if you have a SONET link, it comes is 51.84 or 3 times 51.84 or 12 times or 48 times. There are few standards. It can go up to, let's say, right now about 40 Gbps. So far it's successful until 40 Gbps. Still, even today, it's a successful practical technology which is currently used. Okay, we cannot have like 100 Mbps, 150 Mbps and all. It comes in units of 51.84. Okay. Then came what is called asynchronous transfer mode, ATM networks. That's also could be used in metropolitan area network. Here the bandwidth allocation is flexible, not very fixed or rigid in terms of 51.84. You can have different levels of bandwidth, 50 Mbps, 100 Mbps, etc. It uses statistical TDM compared to fixed TDM. There are some differences which we will discuss on Monday, okay, in the next class. Okay. So let's not worry about this. So right now you understand that these are the good examples of metropolitan area network technologies. Then comes what is called wide area network. As the name says, it covers or spans large geographical area. Okay, the link in terms of the network link. Okay, it can go from one end to the other end of the country, or it can be across the continents. Okay, usually they use point-to-point links, and the links distance could be of thousands of kilometers. Okay. So you can imagine that there is a link which is 1,000 kilometer long, okay, or more than that. And also different countries are connected by fiber links. Okay, earlier only satellite was used for communication between long distance communication between countries, etc. But now fibers are there. Even fibers are laid under the sea to connect different countries. So our data might go through under the sea through the fibers. Okay, so they are part of WAN or wide area network links. There are different technologies used. For example, SONET ATM could also be used in wide area network context, and IP obviously they are used to carry the IP traffic, internet protocol based packets, which we discuss later. But you just need to remember that these are the popular technologies used. And the recent technology which is being used is what is called WDM, wavelength division multiplexing, which is a fiber-based optical network. Okay, so here this is slightly different from others. For example, let's say you have a link. Let's say this is fiber link connecting, let's say, A and B. Even with Ethernet switch or SONET or FTDI, okay, we can use fibers. When you use fibers, fiber-based link, as I said before, the advantage is huge capacity, low bit error rate. Am I right? So earlier initial networks were based on the cables, coaxial cables, etc., or copper-based cables. And when fibers were introduced, slowly they started disappearing, but still the copper-based coaxial cables are used. So fibers are used just a replacement of the copper cables. Instead of copper-based cables, you replace it fiber-based cables. Okay, but still there is a bottleneck. Bottleneck is at the end system. At the end system, or the computer or router, the bits are stored and processed in electrical form. They are not in the optical form. Okay, the transmission is optical. But once it reaches the router or computer or switch or whatever it is, it should be converted to electrical. So we need some kind of modulator or transmitter which will convert electrical to optical, etc. So there are some bottlenecks. Okay, even you take SONET, even though it uses fiber-based transmission, it can go up to, let's say, 40 Gbps. Because on a single fiber, usually there is only one transmission. There are no multiple simultaneous transmissions. With wavelength division multiplexing, we can transmit multiple messages at different wavelengths or lambdas, lambda 1, lambda 2, lambda 3, lambda 4. So many wavelengths can be used for simultaneous transmission at the same time on a single fiber. That means when one transmitter is transmitting at wavelength 1, other transmitter can transmit at a different wavelength at the same time. Okay. So if there are 100 lambdas and each wavelength operates at, let's say, 40 Gbps, this is equal to 4000 Gbps, that's equal to 4 terabits per second. Okay, because many simultaneous transmissions take place at the same time, so we are able to achieve throughput of what is called terabits per second. Okay, we want increasingly more and more capacity. There are two reasons. One, the number of internet users are increasing. Users, when we say not only human users but devices, in terms of devices, okay, increasingly more and more devices are connected to the internet. Not only the computers, but phones, then game consoles, TVs, okay, even other smart devices, they are all connected to internet. So when more and more devices are connected to internet, more and more data are generated, or more data are need to be downloaded. Am I correct? Or uploaded or downloaded. At the same time, the kind of applications are also evolving. Okay, until few years ago, there was not much applications like now what we have. Now what we do, immediately anything we see, immediately take video and then immediately want to send it through WhatsApp or other media. Am I correct? So increasingly we try to download lot of videos, upload lot of videos, images, high quality images, HD images, pictures, etc. So there are many bandwidth hungry applications which need more and more bandwidth, because your video size is big, your image size is big, obviously you need to transmit more and more bits. Okay, so because of these applications we need very high bandwidth links and the networks. Okay. So this is one way. Wavelength division multiplexing is one possible way to achieve terabit capacity. Let me stop here. I can spend some time. If you have any doubts, do you have any doubts? Yes? I understand some students could not make it. Anyway, this lecture is webcast, so others can watch. You can also watch later. Okay? So I want to make one announcement. Okay? The first test, please listen. Later I will send it. The test or quiz from my part will be conducted after the midterm break. That is in week 7. Okay, but I usually conduct on Saturday. One reason is I want to have a bigger classroom. Other reason is there are some evening class BTech students who are also taking the test. So mostly on the Saturday after the break. Okay, be prepared. I'll later send you the schedule once I book the venue where I'm going to conduct it.